So this is a quick review of the notes for conditional statements. As it indicates here, a conditional statement is one that's written in the if-then form. Symbolically, we write it as P with an arrow facing the Q, and we typically say that P implies Q. You could also read it as if P, then Q. Because it's in the if-then form, we can find the hypothesis by looking after the if statement. So as in example 1, if you live in Nashville, then the conclusion of the conditional statement is the phrase that follows the then. Then you live in Tennessee. So we've basically just done number 1. You live in Nashville comes right after the word if, so that's the hypothesis. You live in Tennessee is the conclusion. It comes right after the then. So 2 and 3 can be done the same way. So here we have number 2 and 3 done. So all we've taken is the phrase just after the if statement, or the if to make the hypothesis, and the statement right after the then to make the conclusion. Notice that I gave both statements the noun of which we're talking about in the conditional statement rather than saying they. Same here, I used the noun, a quadrilateral, rather than saying it, so that we would have 2 complete statements. In this next section, it's not as obvious how to write the if-then statement, so we have to take a look at it first. So in number 4, it says, an obtuse angle has a measure greater than 90 degrees. So we have to think about the 2 conditions that are being, or the 2 qualifiers, if you will, that are being stated about the single object. So the object is an angle. So one of the adjectives or qualifiers that describes the angle is that it's obtuse, and the other qualifier is that it measures greater than 90 degrees. So we can use those 2 descriptions of the object, which is angle, to set our if-then statement. So basically, if an angle is obtuse, then it has a measure greater than 90 degrees. And number 5, the object is a number divisible by 4. Well, actually, it's a number. If a number divisible by 4 is the qualifier there, and divisible by 2 is a qualifier here. So number is your object. Qualifier is divisible by 4 and divisible by 2. So in this case, we would write a statement, if a number is divisible by 4, then it is also divisible by 2. So try the other ones, and I'll resume the video. I will put the answers on, so pause the video and resume it to see if you can get those answers. So here are the answers to the rest of them. So states on the East Coast border the Atlantic Ocean. If a state is on the East Coast, then it borders the Atlantic Ocean. If it is Valentine's Day, then it is February. If a number is prime, then it only has 2 factors, 1 in itself. So that's how we go about writing conditional statements based off of other statements. So we have to look at the statement, find the subject, in this case it's number, find the adjective or qualifiers, so prime numbers and has only 2 factors, and so then we can put the first qualifier or adjective in the hypothesis, and then the second one would go in the conclusion. So when we're dealing with conditional statements, we also have to be able to look at variations of those conditional statements. So an inverse just says that we're going to take the conditional statement and negate it. So we're going to negate the hypothesis and conclusion. And if you recall the definition of negate, it just means to change the truth value. So symbolically, we say we're going to not P implies not Q. So it's still P implies Q, but we're negating it. So the order stays the same. We're just changing and taking the opposite of the truth value. So we're not P implies not Q. For the converse, if you think about what a conversation is going back and forth, so the conversation switches between the two people. So we can also apply that same logic to our hypothesis and conclusion. We're just going to switch the order. So symbolically, we say that Q implies P. So we can find the inverse by negating, we find the converse by switching, and we find the contrapositive by negating and switching. And so symbolically, it's not Q implies not P. So you'll notice that we've done both things. We've negated both the hypothesis and the conclusion, and we've switched the order. Okay, so down below, we're actually going to put this into practice and create the inverse, converse, and contrapositive, as well as identifying the truth values. So here are our three statements. So the first one is the inverse, and when we took the inverse, we had to just switch the order of the conclusion to make it the we negated it. So if it is Saturday, then we're going to change it to if it is not Saturday. Then there is no school, we have to negate that, so then there is school. Okay, so we'll take a look at that in just a minute. We want to get through the different types. So then the converse, we took the conclusion and made it the hypothesis, because remember, converse means switching, and we took the hypothesis and made it the conclusion. And then for the contrapositive, we did both. So we switched the order and we negated. So if there is school, then it is not Saturday. Okay, so we basically could look at the converse of that and make it the negative. All right, so now we have to go back and identify the truth value. So let's look at the inverse. If it is not Saturday, then there is school. Well, but if it's Sunday, then there isn't school either. So this really isn't a true statement, because if it is not Saturday, then there is school. So that means if it is Sunday, then there would be school, which we know is not the case. So this would be a truth value of false, and we would also want to offer that counterexample of it being Sunday. So we would specify that. Okay, so when we look at the converse of that, we'll discover that it also is false. If there is no school, then it is Saturday. Now, there's no school on Sunday, so again, this statement is false, because we can't absolutely conclude that it is Saturday just because there's no school, because there's no school on Sunday either. Okay, but the contrapositive, let's take a look at that. If there is school, then it is not Saturday. So if there is school, that means it's Monday, Tuesday, Wednesday, Thursday, Friday. So it will never be Saturday if there is school. So that particular truth value would be true. Okay, so I'm going to leave you to do number 2 on your own. If the product of two numbers is odd, then both numbers must be odd. So do those 3 statements, getting the inverse, finding the converse, and the contrapositive, as well as identifying the truth value. Resume the video and the answers will be there. Okay, so here's the 3 different statements. So taking off for the first one, we had to remember to write the inverse, we had to negate the 2 statements, the hypothesis as well as the conclusion. So if the product of 2 numbers is even, which obviously is the opposite of being odd, then both numbers must be even. So we just negated those 2 statements. The converse, we switch the order. If 2 numbers, are odd, then their product is odd. Okay, and so we just reversed the order, and notice that that we used the subject at the beginning and put the pronoun later. And then the contrapositive, if two numbers are even, then their product is even. Okay, so now we have to think about the truth value. So recognize that the contrapositive, we just negated the converse. So we took the converse order and changed to be the opposite. So odd to even, odd to even. Okay, so now we need to look at their truth values, and if anything is false, then we have to offer up a counterexample. So if the product of two numbers is even, then both numbers must be even. Okay, so we have to think of a product that is even. So let's just pick the very first one, 2. So the product of, if we have the number 2, what are its factors? Well, 2 times 1 gets us 2. Well, here we just broke the statement because 2 is even, but 1 is odd. So the truth value to that would be false, and we could mention 2 times 1 equals 2. Okay? So now on the converse, if two numbers are odd, then their product is odd. Okay, so if two numbers are odd, then their product is odd. So we're looking for odd numbers multiplied together because we first want to take the hypothesis and try to see if we can make that conclusion. So odd numbers, 1 and 3. Okay, they make 3. 1 and 5, 5, 1 and 9, 9. Okay, so 1 and any odd number is going to make it an odd product. But what about 3 and 5? Well, that's 15. 3 and 7, that's 21. 3 and 9, that's 27. It's looking like we probably do have a truth in this particular statement, so we're going to call that true. And then the contrapositive, let's take a look at that. So we can do the same thing to the contrapositive and go through a bunch of examples, and we will find out that that also is true. Okay, so work this last example and resume the video to see the answers. Okay, so here's the answers to that problem. I hope this all makes sense.